Hello everyone and welcome back to AMOS, our course on Agile methods and open source. In the past few sessions we looked at how we apply Scrum in a university setting. Starting with this lecture, I will take a step back, provide the underlying concepts and motivate Agile methods so you know when to apply it and when not. To do so, I will look at the key business functions that people play in software developing companies. And that then lets us describe process models and in particular then plan-driven development, the precursor and still current competitor to Agile methods, and then of course Agile methods itself. So the first key business function in a software development organization which sells a product is product management. In companies like Microsoft or Google, there are people, product managers, and they are responsible for motivating products. Why do we have that product in the first place? They have to write a business plan all the way down to small fine-grained details, where does the button go, and so forth. And depending on how high up in the hierarchy they are, they may be responsible for the whole product. They might even be responsible for a whole product portfolio, like say Microsoft Office, including Word and Excel and so forth. So the fundamental question, and it's perhaps the most important question to ask, the fundamental question that a product manager asks is, what is it that we should be doing? That is, what's the meaning, what's the purpose, what is it that we should be doing? And then once you understand where you want to go, you have to map it into reality. So then you also rank order by priority what it is that you should be doing, because once you have a high-level goal, you've got to break it down into steps, and these need ordering because you can't do everything at once. So you ask first, what is it that you need to do? And then you ask in what order or what of the things to do should be done first and what should be done next. Traditionally, software product management is split into these two related functions or parts of product management. There's the strategic product management, which really focuses on the overall reason of existence of a software product being developed for a market. And that typically leads to a business plan of why we should have, or the company should have that product, why the resources should be invested to develop it and to market it and so forth. And that leads to the business plan, also called the marketing requirements document in older terminology. Also, product management is making that specific then. So it's having a high-level, lofty goal of let's develop a word processor is no good if you can't break it down into small features. You need to break it down, and that's what technical product managers do. So they focus on the nitty-gritty of specing out a particular product to be developed. And that leads to the product requirements document, the requirement specification for a product, or the product backlog in Scrum. So you can see here the key processes of a product manager to the left and the output it generates. They need to understand market opportunities, and that leads them to write business plans or marketing requirements documents. That's what a strategic product manager would do. Or they have that idea, they got the sign off, let's develop that product, then they need to write a product specification, which is also called the product requirements document or product backlog and so forth. Once they get going and maybe a product is successful, they need to have a roadmap for the product, not just what are we doing today, but also over the next few months, over this year, over the next few years. So beyond day-by-day planning, there should be a roadmap that leads the way for the product into the future. Typically, there's an internal one that you use internally for managing software development, and then there's an external one you communicate to customers. You also, as a product manager, perform release planning. You prioritize and you list what needs to be done for a particular release. As a release has high visibility usually to customers, what gets in, what's cut out, these are important business decisions. So when I say product manager, I take the perspective of a so-called software vendor. A vendor is a company that builds products and sells them to a market, meaning there are many customers that are somehow similar, hence market and market segments. So Chrome, the browser, is a product for a market, Microsoft Word is a product for a market, and so forth. And in that situation, you have the distinction we just discussed. You have strategic product managers who motivate the product, and you have technical product managers who get into the nitty-gritty details of determining requirements for the product. Now, there's a very different setup you might run into if you work in industry, which is you might be working for a consultancy. A consultancy or a consulting firm is quite different from a product vendor because you don't deliver products to a market, you deliver custom projects to one single client. So the resulting difference is that the requirements are easier to get to, arguably, because there's only one customer, not a whole market. And in this context, product managers, or the people who determine requirements in more general terms, have different names. So, for example, they're often called business analysts, sometimes project leader, because the project leader also then is responsible for requirements, but obviously also does more. Could be a senior business analyst, and so forth. You obviously don't see Scrum terminology here yet. It's debatable what exactly of these is the product owner. In some people's book, everything. In other people's book, nothing. We will ignore this discussion and introduce product owner later as part of Scrum. You need to understand there are people who are responsible for requirements. That's the focus from the high level, abstract, why should we be investing resources to have this done, all the way down to where should the button go. Now, if you have time to then go to this YouTube video and watch the 10 minutes clip of from the movie The Pentagon Wars on the new Bradley design. It captures 10 years in the life of a project manager. I hope you have the time. I will wait for you. Yep, I wait for you here. Are you gone yet? Will you come back? I will still be here. So I trust that you push the stop button here, watch this video, and I usually discuss that in class. The key learning from this video is one of the biggest problems that you could have, both in a project, sometimes also in a product. It's called feature creep, meaning the requirements keep evolving, are never stable. Something gets added onto it. Sometimes things get changed because they were not cleanly specified in the beginning to start with, and so forth. And that has the worst possible consequences on hitting delivery targets, developing a product that actually makes a project that actually makes sense, and so forth. So I hope you had some pity on that poor project manager and definitely do not want to end up in their position. So in a traditional software developing company with products for a market, the product manager has a natural counterpart within the engineering department, and that would be the engineering manager who performs engineering management. So that's the overall management of the processes of developing the software, like with a product manager along a whole product lifecycle possibly, or even across a whole product portfolio. The engineering manager is responsible for all the software developers. And so it's not the requirements, those come from product management. The engineering management is concerned with turning those requirements into workable software by way of software developers. So their main concern is looking at the requirements. Their main concern is who gets to do what and who is the suitable person to do this or that. You wouldn't give a user interface feature to a back-end developer because they're no good at it, or probably not good at it. So the engineering manager looks at their resources, meaning their developers, and assigns tasks in a classic sense. They have a secondary question to ask, which is, all right, so who gets to do what and how quickly can they be done? Because almost always there will be pressure to do things as fast as possible. So you look at Slack or not having Slack in the timeline as an engineering manager and so forth. You deal with release planning together with the product manager. Typically, you can tell the product manager that you think this requirement or that requirement will take so many person hours or days or weeks. So you can help with the product manager who prioritizes. You can tell them how much can possibly get done. As an engineering manager, you need to understand technical interactions, because sometimes even if you would have a person, if they can't build on what they need to do the job, then they can't do that job. So feature dependencies need to be resolved, and the product manager may not necessarily see the technical dependencies. Key to engineering management is assigning tasks to people. So you have your project plans, task boards, and so forth. Sometimes you outsource, which is its own challenge, a challenge in its own right. And you are responsible for process improvement. So an engineering manager looks at the overall processes and always looks at how could that process be improved. So for that, you might, as an engineering manager, might do a project retrospective. So for each product manager, there's an engineering manager. Sometimes for one product manager, if they're responsible for multiple products, there may be several engineering managers. Usually it's a one-on-one relationship. And there's only one product manager, meaning the product manager doesn't have subordinates or junior product managers working with them. That is different with the engineering manager. They have resources, they have the people. So the engineering manager has software developers assigned to them to get the job of developing the software done. So that's what software developers do. They program, they turn the requirements as assigned to them by the engineering manager into working software. Straightforward. And hence the main question is, how am I going to do that? How am I going to do it without breaking the existing code base? How does it fit into the architecture? How many tests do I need to write? And so forth. They also often help the engineering manager estimate how much time or how much effort it will cost them, because while an engineering manager has to understand technology and what people are doing to some extent, they naturally, because they deal with several, if not many people, will not be so close to the matter, to your code, that they can always get it right. So they absolutely need to consult with developers as to how complex a feature is and how much time it will take. The engineering manager needs that for release planning, and the software developers obviously want less pressure on their back and hence want reasonable estimates. So the software developers, they're very much focused on programming, so they deal with source code all the time. Sometimes they help with effort estimation, which makes it into the product managers and engineering managers' release plan, even roadmap possibly. The fourth function to look at in traditional companies is quality assurance. So quality assurance is the process and the people behind that process that make sure that the software under development has a defined quality, where defined means meets the expectations and needs. And hence the question is not how to make it perfect. The question is it good enough? Can we release it to the customer and it serves its purpose within the expectations? Or is it not good enough? If it's not good enough, quality assurance really needs to hit the big red stop button and tell them that no, this is not going to fly. Hence, you need to fix all the bugs or fix the user interaction issues, what have you. So quality assurance has to make sure that the software will not embarrass the company. How do you know that you've got the right quality? Well, as I said, it's not absolute. So 0 bugs is not a good measure of quality because there are no 0 bugs, and it also does not take the context into account. Quality is if you agree or if your software conforms with the expectations, again, of the stakeholders. Then you've reached sufficient quality. And that is not necessarily easy. Product management has expectations. The functional requirements, the non-functional requirements should be there. Engineering management doesn't want a maintenance nightmare, so they want a certain code quality. They want evolvable, clean code. They want to evolve the software. Support and operations needs to look at their own functionality. Is the software good enough for operating it? Will it not be of high costs because it's got a stupid architecture, and so forth. So there are various stakeholders, not to mention the main one, which would be customers as represented through product management, but these stakeholders all interact with quality assurance. So quality assurance typically has a quality assurance manager, like an engineering manager, like the engineering department has an engineering manager, and the quality assurance manager has quality assurance engineers, or sometimes just test engineers, though quality assurance should not be limited to tests. But yes, indeed, the various test processes are a key part of what quality assurance engineers do. Automated tests, writing unit tests, writing integration tests, but also manual tests used with a human eye testing the software, and so forth. The quality assurance manager has a right usually for signing off, or is the one who has to sign off on a release before it goes to the customer. And before they sign off, the engineering manager is on the hook. Once they have signed off, they are on the hook more than the engineering manager. So these 4 functions, product management, engineering management, and software development, and quality assurance, must have a place somewhere in an organization, agile or not. Usually, we will discuss it now. So here's a quiz. Where would you put product management? Meaning, where in the organizational chart? Imagine a classic hierarchy with superiors, managers, and their subordinates. And you would have a sales and marketing department, makes sense. An engineering department also makes sense. Where would you put product management? Into one of those, or would you make it standalone? Hit stop, think for a second. I'm still here. So, about 60% of companies have it in sales and marketing, 30% perhaps in engineering, maybe 10% roughly make it its own department. If you put product management into sales and marketing, what's the possible problem? The possible problem is that a salesperson will convince the vice president of sales or the head of the org unit here that if there was only this one feature for that one customer, there would be this big deal and the company would be great and everyone gets a bonus. And suddenly the product manager has this pressure to promise this feature even though there is only this one customer, while the responsibility of the product manager is making sure they hit the whole market. You're not a project company. So sales and marketing will lead, if product management is in sales and marketing, it will lead to a frazzled product easily, with too many little bits and pieces that make only sense for one particular customer. In engineering, it's the inverse. The engineering manager doesn't care much about deals with customers, but they do care about code quality and evolvability and having a future happy life. So they may pressure product management to give them more time for refactoring and cleanups and so forth, which may not always really be needed, and it would be better to get new features done. So I would argue the best place for product management is if they are standalone and neither the engineering manager nor a sales VP can pressure them into accepting silly features because of just one customer or deal, nor letting go of the focus on creating business value for customers and the company itself. All right, where to put quality assurance? Well, if you put it in engineering, and so the VP of engineering, the person who's responsible for all of engineering, has the quality assurance manager as a subordinate, they could pressure them into, come on, let our product through, won't be so bad, which absolutely you don't want to. So usually you try, even though that's the most common place for quality assurance, you probably shouldn't have it in engineering. Some people argue you should put it into product management because that is where you really want to make sure that the customers are not disappointed. So product management could use quality assurance as a way of managing expectations right with customers and the market. But some also argue you just should make it stand alone because the ability to say no to a shoddy product or problematic release is so important that nobody should be able to pressure our quality assurance. So we talked about the key functions in software development, at least in a vendor's context, but also applies to consultancies. So product management, engineering management, and software development, and quality assurance. Now we need to take a look at how these people or these functions usually performed by different people. So there's a one-to-one assignment between the business function and a person. How they interact and collaborate to carry out a software process that at the end delivers great, useful software. So that's what a software process does. Well, it's a process that delivers software, and a model of that is a model of how to deliver software, how to run a software process. We talk about models because you go from one company to the next. Of course, you both want the best possible process, so they need a model. So the idea is not everyone has their own process and they're all not comparable, but they fall into categories, hence Scrum and so forth. So we talk about the roles and practices that people play, the artifacts they generate, and so forth, really from a modeling perspective to create a valid process. So at some point of time, there were so many models for a company that asked how can we most efficiently develop software that it became really hard to understand those. And the problem was the model tried to capture all situations. And if you really capture all possible situations, you naturally get very abstract. And that is what Scott Adams is poking fun at here. There were so many descriptions of how to run a software process on such a high level that it made little sense to anyone any longer. So let's keep it really simple and thereby introduce both plan-driven and agile software development and agile methods. So the really simple view that I came up here with, it's very obvious, is you need to perform at least some sort of planning, what you're going to do. then actually do it. Step 2 here, or part 2 here, execution. And then you do need to close a feedback loop by reviewing whether what you did during execution actually matches what you wanted to do in planning. And the outcome of that review is obviously, is it good enough or not? The quality assurance question, should we release the code or not? And that's what you do. These are the key activities: planning, doing, and reviewing. When you look at software, then you do that possibly multiple times, and you do it over different stages in the life cycle of a software. So these activities may be different depending on whether the product you're developing has not even been released yet, or is in the market but growing rapidly, or is so mature that it's really just being maintained. So all of that can vary. As you perform these activities, you have to plan. And so I want to show you here the probably well known from your basic software engineering lecture magic triangle with a twist, and then also with respect to agile methods later. So the magic triangle really says that of 3 things, so the version I use here, of 3 things: scope, quality, and time, you can pick 2, and the third will follow. It's not really a triangle because there's a 4th factor. There are actually many other factors which are assumed to be constant. So if you wonder about cost or number of people, that's strongly correlated, then it's assumed to be fixed. So cost is assumed to be fixed, meaning you have a set number of people, and that's where your costs are, the salaries of the software developers usually. And if that's fixed, the manpower you have, the resources you have don't change, cost stays the same. Then you can think about scope, time, and quality. Scope means features, how much functionality will you get done? Time means deadlines, by when will you get it done? And hence, for example, if you say like in 2 weeks we will get all these features done, so you just fixed time and the feature scope, then the quality will follow. That's the idea of the magic triangle, using scope and time as fixed. If, however, you say, well, scope is there, so these features are to be done, and we want to reach this particularly high quality, now you have fixed the time. It follows from scope and quality. And you cannot, even if there is a raging product manager, engineering manager who says, it needs to be done by the next weekend. If it's not in scope and quality dictates it needs 3 months, then you will not be able to get it done by next weekend, unless you start varying scope or most notably quality. So you pick 2, the third follows, and here in software development we almost always assume fixed costs. So historically, software development started 50 years ago, and people didn't really have a good idea of how to develop software at first, and at some point of time people realized that software really is an important part and needs a more structured process, and hence they came up with what's today called plan-driven development, and of which the Waterfall model is the most prominent example. And the idea of plan-driven development is that rather than just not plan, not do anything at all, just jump head first in, you really should think through your project or product release from the start to the end. Meaning you have something you want to achieve, so you have a process in which those activities that I talked about, planning, execution, review, and release, those activities are chained, performed in sequence, and exactly once. So there's exactly one run through where you plan once, execute once, review and release once. And that was based on the idea, no, we don't want to rework. We want to get it right from the beginning. So to do that, We just need to plan thoroughly. Give us the time, people thought, give us the time to think things through, be precise, make good plans, anticipate all the problems, and if you let us do that, we will always see the problems in advance and make sure we don't run into the problems, and hence execution will be smooth and we will be releasing a great product or project at the end. And people thought that this could be done for time frames of up to 5 years. So plan for half a year, execute for 3 years, review, release for the remaining time. The key of plan-driven development is at the beginning you plan it all out and then you follow that plan. The namesake of this approach is, as mentioned, the waterfall model. So a waterfall model, you can see the original graphics from the paper here, and you can see how it's not just the basic planning, execution, review, but many more phases, kind of in this waterfall falling down. So first you determine system requirements, then software requirements, then perform domain analysis, then you design the program. Only then do you start programming, then you do testing, and eventually it's put into operations. So while I just talked about these 3 activities, planning, execution, review, it's already several more here. And when people started applying the waterfall model, it quickly escalated in that it was hard to get it right. So they added more steps or more stages in this waterfall. They added more analysis, they added more program design, more architecture, high-level architecture, low-level architecture, system design, programming, and so forth. Simply more steps, all to be planned out in the beginning in order to make sure that projects were successful. The problem with that is that, as already mentioned by Royce here, you perform something and move on. And as you move on in doing what was planned, you learn something that shows what you previously planned isn't actually true. So while the waterfall flows from left to right, downhill, and that would be the preferred path, there are these arrows back. So already the original author of the namesake process model waterfall realized that you learn along the way, which will make you want to go back to earlier stages in this process and change things so you run over the waterfall or you fall down the waterfall again. So in testing, you learn something about how your design really should have been. And as you change that design, you learn something about how you didn't really get the requirements right. And this ability to change the plans was not anticipated or was not part of waterfall of the waterfall model, nor was it part of the idea of plan-driven software development. So here are some fun aphorisms about how difficult it is to plan correctly, because you are predicting the future. Prediction is very difficult, especially about the future. If you could predict the future correctly, I wouldn't be here. I would be speculating in the stock market. Well, I wouldn't be speculating. I would just be making a lot of money if I could predict the future. Plans are worthless, but planning is everything. So that's the second thing. From knowing how unlikely it is that the world will conform to your plans precisely, the actual activity of planning is important, because you are thinking about the future, you are preparing yourself for what might happen. And even though you charter a course, meaning set up a plan and follow the plan, you have the understanding that things could go wrong and that you may have to adjust. And that is only possible if you are actually planning for alternatives, planning for contingencies, stay nimble. So the planning leads to learning before you do and makes you more ready to adapt to a changing context. And here's the key insight from all of this. the mistake, arguably, that plan-driven development made is to assume that these activities that I talked about on the highest level, planning, execution, and review and release, these activities, they are needed, but they are activities. There is no implication that they have to be performed in this particular order, how I list them, nor is there any requirement that they be performed only once. Yes, it makes sense to go from planning to execution because maybe you should plan and think ahead, but as you execute, you learn something, could go back to planning and not move on to review. And even if you, after review, you might go back to the beginning because you learned so much that you have to do it over or incrementally build it out. So no hard requirement of a particular order, and also no particular requirement that you do the activities only once. And hence we don't have necessarily these phase models any longer, but something called Agile methods. So let me motivate Agile methods here by way of a short video. The person you'll be seeing here, I'll be talking over him. This is a Bavarian inventor, not a Franconian. He's a Bavarian, so he says things that are not particularly relevant, stuff like Back mal and Burschen und Anzapf dies und Jodel do, du dödel die or so. It's not really important. What he has done is he has invented frictionless or nearly frictionless material that he has turned into this wetsuit, and he's going to demonstrate how well this frictionless material works by writing down the slope in this wetsuit of this frictionless material. All right. So that was his flight path, and as you can see, because of this material, he was able to fly well, hit the spot, all nicely calculated. So a big question, of course, is, do you believe that? Was that true? So I hope you didn't believe it. It was a spoof video. The thing to understand here is that this was a kind of a joke, but here is how it would look like in reality. So here we can hear him again, and that was the wrong video. Here's the right video. The making of Mega Rouge. So this is a stuntman, and he's going down, and you can see how halfway already, so he's on a rope, so to not really slide down further, how he is not going straight down the ramp any longer, and he never gets off the plane. So the video lesson here is that you really can't predict this flight. Just imagine you take off like this, and there's a gust of wind. You can't predict the gust of wind. It takes you a few centimeters to the left at the beginning, and that will make you miss your target, the water. You will be 1 meter off just because of a small gust of wind when you took off. So you'll get off track easily, and that's the problem with planning. If you get off track at the start, there's no guarantee that half a year, 2 years later, you will still achieve the desired outcome. Small changes have big effects. Flawless execution is basically impossible. So understanding that you simply could not plan 100% precisely, people came up with Agile methods. And that it was invented in the late 90s in response to plan-driven software development. It certainly had its weird moments because it was really consulting-driven business. but it has this true core of plan-driven development being so poor and overly ambitious with respect to making plans that never work out. So the key insight was that, again, activities should not be simply mapped to phases in the single-minded way of plan-driven development, but rather you should iterate over these core activities many times possibly until you hit it right, and that would lead you to multiple iterations rather than just one run through as in plan-driven development. Agile really has all these variations of development methods. Scrum is the one that came out basically on top. And they were really marketing savvy. So here's the manifesto with a picture of the those people who wrote it, being able to quite nicely capture the values of Agile, in particular in juxtaposition to plan-driven software development. So it is individuals and interactions in this manifesto. The people and how they collaborate is more important than following strictly a process and using a particular tool that's forcing you into that process. Working software, meaning being able to show a demo of the software and gather feedback from that, is more important than documenting everything up front and sticking to that documentation. Working with your customer, learning from your customer, letting your customer steer your work is more important than defining a plan in the form of a contract with your customer and then sticking to it until the bitter end. And of course, responding to actual change and reality in the regulatory environment, in the businesses, in the markets is better than strictly following that original plan. These are the principles of Agile software development as encoded in the Agile Manifesto. So again, this has led to software development being a sequence of iterations, where one iteration arguably is a little small plan-driven project, but not of size 5 years or 2 years, but of size 1 week or 2 weeks, depending on how long you make your iterations. To keep things simple, the iterations are chained and they're usually of the same length, so it's equal length iterations. You always make your iteration 2 weeks long or 1 week long. And in Scrum, the iteration is called sprint, it's called time boxes or iterations elsewhere. And the purpose of having these iterations is that it defines intervention points, for example, from customers, where you get the feedback that lets you steer the software, but you get the feedback at a defined point of time. It doesn't randomly show up in the middle of execution where it would be confusing, but it shows up at the end of your time box where it's still so timely and close to the action that it's really useful feedback and helps you manage and steer right, but it also doesn't disrupt you in the middle of doing. So the basic activities of planning, execution, review, release, and retrospective, and Scrum, or how we run Scrum, they are still chained in exactly that sequence. But they are iterated over in time boxes that are in AMOS 1 week long, in industry often 2 weeks long, and so forth. So that after 2 weeks or 1 week, you go through that review cycle where you gather that feedback that helps you realign, readjust what you did to better meet their requirements. So these short iterations let you gather feedback quickly because you also have to show something or want to show something. It implicitly leads you to focusing on high value first, so you don't delay working on what really creates business value for customers until the end, because in the meantime nobody cares. But because the day of reckoning or the review comes soon, you focus on what's high value first. You create a well-worn work rhythm that's hopefully sustainable, and again, it enables you to gather this feedback that you use for identifying problems early, identifying changes, and getting to innovative features. So here you see an illustration of classic plan-driven development, what happens, and agile methods. It's pretty obvious, hopefully, by now. If you have 5 time periods and you follow a plan-driven process, and at the beginning you're in state 1, and after 5 time periods following the plan, you're in state 5, then if the target where you want to be moved from over these 5 time periods from T1 to T5, and you followed what was defined for T1, you can be pretty far off from where you want to be. Agile methods, if you get that intervention after 1 time period rather than only hear about it at the end, lets you adjust. So 1 time period is over, so you started as 1, you go towards T1, target 1, you reach state 2, S2, you realize target shifted, you orient yourself towards T2 to meet the new target, move to it with S3, you're in state S3, target shifted again, and you follow that target in small increments, you adjust, then you will be much closer where you want to be than if you follow plan-driven software development. So these short iterations, the feedback you get lets you adjust. Another aspect of plan-driven versus agile is that plan-driven software development in a sense is actually more relaxed for most of the time, until crunch time comes, of course. If you have 2 years for a project, in the beginning everything will be easy. You're making your plans, things look nice, you have no expectation that the plans wouldn't work, but eventually over time you realize you might not make it, you readjust perhaps, or still stick to the plan, and you're putting in more and more hours. So initially it's relaxed, and then eventually comes crunch time when you want to release, and so you have this workload initially in the green over 2 years, and then crunch time, bad, hard work possibly. Agile methods, where you adjust after each iteration, may in the small also have that first day is a bit more relaxed of a new time box or sprint, and then near the end maybe put in a bit more, but it will never have the amplitude of plan-driven development. You have these small cycles that in total are much easier to comprehend and lead to a more sustainable work rhythm. This work rhythm, these short feedback cycles, put agile software developers into a skeleton or this process. Some call it a straitjacket, but ultimately what it does is it guides you. It also makes you high discipline because it is so much more prescriptive on what to do. And in a sense, you have to be much more disciplined than in plan-driven development, where even though you follow a plan, you're left alone until the feedback comes, much more than in agile methods. So agile methods are not cowboy coding, they are much more disciplined, and some argue restrictive than plan-driven software development. Let's take a look at what this means. So how about you're a consultancy and there's a customer and they say, I only have this money, go do the thing, I can only pay that much. So it's a so-called fixed price project. Which type of approach works best for that? Plan-driven software development, agile methods, or open source, which we didn't really discuss yet, but so just A or B. Well, you should only accept a fixed price project if you can actually really plan it through, because then you will know whether the price is reasonable or whether you will lose money. So under the assumption it's sufficiently small and you can actually follow a plan-driven process, then probably it's best for fixed price projects. Because otherwise, if you can't plan it and you get this amount of money, but you have no idea whether it's enough to cover your own costs, you probably shouldn't take the project. How about time and materials projects? So the customer says, give me your daily quote, a number of people, how much is that, and we will pay for your time. Well, that calls for an Agile methods process, because Agile methods does not promise in general a specific delivery 2 years from now. So if the customer is willing to accept that, then the customer relies on you to be honest and truthful and doing hard work, but then they pay you by the day, or in some way correlating to the time you put in, and they will get what you develop. And if you're good people, you will actually always deliver business value first, as we will see, and hence the customer is actually benefiting with some useful software all the time. I dropped open source from this part. Open source is nicely suited for collaboration across companies, hence question 3, inter-firm collaboration works well with open source processes. And that's it for this session. I talked about the 4 key functions in traditional software development and the key process models that we know today, or the categories plan-driven development and Agile methods. And in the next section now, we will see how specifically Scrum takes these key business functions and takes them apart and puts them together for a new Agile method, that is Scrum.